Hi, today I'm going to run you through how to train a simple CNN model using PyTorch. This is going to be used for a yolov8 model, and we're going to create the model, train the model, and afterwards we're going to test it on an image test file where you can upload your own image to be tested, or we could do a webcam test over here, which allows you to look at these to test this model on your webcam. So the first step, we're going to do the model training file. First thing we're going to want to do is import all of the necessary libraries. So we're going to import pip install torch in your terminal, and you're also going to pip install torch vision. Okay, so that's the first step. Of course, we need to import the necessary libraries. The next step is to set up the data transformations, and this resizes each of our test images and images we're going to train to 256 by 256 pixels. Afterwards, we are going to load the dataset using this directory. And basically, how you're going to do that is create a dataset file, and in that file, we're going to put in files with folders with your image files in them. And each folder is going to be the class, so you want to label them with the class, and you can see I've got like lots of images in each file. And basically what this does is this loads the data set, and each of these folders are your classes. So I've got 7 classes here: biological, cardboard, glass, metal, paper, plastic, and trash. Yeah, so this is pretty easy. Now this just lets us confirm that we're doing this correctly, and this will just print out the classes and the number of classes. And it's really good for troubleshooting, so I recommend doing this as well. After this, we get to the fun stuff where we define our CNN model. Basically, you don't need to know this, but it consists of 2 convolutional layers, followed by a max pooling layer. So you can see max pooling, and afterwards, it adds the 2 fully connected layers at the end to handle the classification. So this is like the really fun stuff. After, okay, yeah. So the next step is to train the actual model. So we need to define a loss function and an optimizer. So here we're going to use cross entropy loss, which is a standard choice for classification, and it works well in most cases. So that's that. Afterwards, we're going to train the model further with everything set up. So this is basically setting up everything, and here is the really cool stuff where we're going to train the model. And you can see I've set, you can change this, but I've set the number of epochs to 5, because I like for my, at least for the files in mind, I think that's like a good number. You can increase it, but if you do it too low, the model might be inaccurate. And if you do too high, it'll be inaccurate, because if you do it too high, it runs through it so many times that it picks up on the really minor details, and it could think that a minor detail makes it seem like all of these things are part of a class. So that's why I set mine to 5. I might go higher, I haven't tested it yet, but this is what I've set mine to. And finally, it saves, when it's all finished training, it saves the model as a PT file, and you'll need to adjust this to where you want to save it. So let's say I want to save it in my in a model file over here. I am going to copy the path, yoink the absolute path, and then replace it here like that. And also the thing, in at least in PyCharm, I'm not sure about VS Code and other softwares, but you're going to want to replace this with, you're going to want to replace all of these with like Control R to replace these with forward slashes, because for some reason PyCharm likes it like that. I'm not sure why. And what you're going to do, you see you've got the models file, you want to do another slash and then save it the name you want. So I want maybe model test.pt, and that will save it as a PT file, and we can use that PT file in other files for example, in image test, we'll load that model as a PT file and use that, which is really cool. And that's basically done. That's how you train your model. So if we run it, you can see that it outputs the classes over here, and this is correct. We can see in our dataset model, we have biological, cardboard, glass, metal, paper, plastic, trash, and the number of classes 7. So we can see it's all correct. And although this will take a while, it's worth it because you get to train your own model. It's really cool. So yeah, that's basically training your model. I hope you enjoyed that. Okay, so now that we've trained our model, we can do a image test where we test out an image on our model. So we're going to load the pre-trained model and then test the image on that. So what you want to do first is import all the necessary libraries, and then you want to transform the image so that the program can actually run it on the same size that we did for our model. Then we define and load the model. So we're going to do similar to what we did when we were training the model. This is defining the class, defining the model. Then we're going to load the architecture in. So num classes, you have to change to the number of classes you have. I have 7 in mine, so I'm going to set it to 7. Then we load our model, and this depends on where you saved it. You want to copy in that path into this code, and we saved it as a PT file, so we're gonna, it's gonna be a PT file. And you have to be careful here. You want the class names to be the class names exactly, and it has to be in the same order. Otherwise, it'll output a different value to what you want. Step 3 is to run the inference on an image. So we're going to create a function here with the image path being down here, test image path. And we are going to, basically this code allows us to run, for the model to run on the image and give an output. And over here, like it just shows our outputs here, and then it returns the predicted class index. And we use the class index to get the predicted class name, so that's why it's important to put it in order. And this bit at the end, this is just to output the name of the class, and there you go, you have it. Over here you can put different things, so I'm using this project to send a signal to Arduino. So over here I would import serial, and then use serial to send the broadcast to an Arduino. But this is just import what you want to do, so maybe you want to print something else depending on the class name, so like if predict the class name is equal to something, or something like that. So that's really cool. Just before we go to our webcam test, I just really want to quickly show you that the image test actually works. So I'm not sure what test image I've got here. Let's check. I've got a beer bottle. So that should output a glass. So if I run it, then in the terminal, it should output glass. Ignore this error. I'm pretty sure you can get rid of it, but it doesn't really affect me, so I'm just not going to. And over here, you can see that the predicted class name is glass. And if we go to our test files, beerbottle.jpg, it's definitely glass. So that was a success. So now that we've done our image test, we want to do our webcam test, and this will detect it frame by frame and output a value, output the class that the AI thinks it is, or LNN, I'm not sure. So basically what we're going to do, we're going to import the libraries like last time. We're going to transform the image, resize it into 256 pixels. And it's very similar to last time. We define our CNN, and yeah, this is basically everything we did last time. We set the number of classes, I've got 7. We upload the weights or the data train model as a PT file. Then in the correct order and the correct names, we do the class names here. Now slightly different this time, we run an inference frame by frame here, and this allows us to record with our webcams instead of being a single image. And basically, instead of outputting the class name in the terminal, all we're going to do is we're going to print it out on the screen on the webcam. Over on here, you might notice that there's 0, and this can change depending on how many webcams you've got. I've only got 1, so I'm going to set it to 0, but it could be different depending on your webcam. You have to play around with the numbers a bit. And over here, it's just a bit of troubleshooting. So if you can't open the webcam, you output an error. If you can't read the frame, you output an error. And this allows you to troubleshoot and see what went wrong. If it does go wrong. It hasn't gone wrong for me yet. And you can see over here, this is how we output the detected class. And we're going to output it on the screen on our webcam like viewer. And it outputs the predicted class. So if we run it, then hopefully it should work. Let me see. There we go. So this is me, and you can see it. For some reason it thinks I'm metal, but hopefully if I hold up a piece of paper, it might think it's, I mean, sort of. It's not a very good webcam, but it should work, and if you're facing it down, then it should work even better, because it's basically just a picture. So thank you for watching the video. If you want more content like this, then please put what you want in the comments, some tutorials, maybe some 3D modeling, things like that. Also, it would be a huge favor if you could like and subscribe, and it would really boost my confidence in making more of these videos. Thank you.